you have graphed it correctly, it should look something like this. You guys see that? Anybody's not look like that needs me to help them enter the equations. Everybody's good. Okay. So choose any two of the lines, or just all three of these lines. How are they related to each other? What can we say about these lines? We said they all have the same slope. Parallel. Do you guys know what parallel is? Parallel lines. So these three lines are all parallel. That's part A. What made them parallel? They had the same slope. So the whole point of that beginning exercise is we have learned this. Parallel lines have the same slope. We could also say the converse of that is true, which would be lines with the same slope and different y-intercept are parallel. So parallel lines must have the same slope. And if lines have the same slope but different y-intercepts, then they are parallel. Why did I have to add that about having different y-intercepts? What if lines have the same slope and the same y-intercept? Just the same line. So it can't be parallel to itself because it's the exact same line. So that's why I had to add that little extra bit. Questions there? Okay, so here's our first problem. In this information. I need to write an equation of a line in slope-intercept form. Okay? What does slope-intercept form look like? Y equals mx plus b. It must go through this point, and it must be parallel to this line. So I'm supposed to be writing the equation of a line in slope-intercept form that goes through a point and is parallel to a different line. So let's start with the newest thing we've learned. So that would be what I have in purple. It must be parallel to this line. What do I know about parallel lines? Same slope. Can I tell the slope of this line? Why? Because it's already in slope-intercept form. So it's easy to identify the slope as 3 over 4. So if the slope of this line is 3 over 4, and my line is parallel to this line, then the slope of my line is 3 over 4. Is that easy enough? And this is because it's parallel. Make sure you know your definitions because we're going to learn about a different thing later. So remember, parallel, same slope. So my line has a slope of 3/4. What else do I know about my line? It goes through the point 8, 9. So I know a point and the slope. So I'm going to put that in point slope form. because that's what I was given, was a point and the slope. But it wants the final answer in slope-intercept form. So once I put it in point-slope form, I will have to convert it to slope-intercept form. Everybody buying that? Everybody's on board. So what is point-slope form? Y minus y1 equals m times x minus x1. Substituting in, that would give me y minus 9 equals m times x minus 8. Everybody still with me? Stop me if you're confused. This is putting everything together in one problem. So this is point-slope form, but I don't want my final answer in point-slope form. I want it in slope-intercept form. So I must distribute. 3/4 times x is 3/4 x. 3/4 times negative 8 is negative 6. Bring down the y minus 9. Still not in slope-intercept form because of the minus 9. So I need to add 9 to both sides. Going to give me y equals 3/4 x. Negative 6 plus 9 is a positive 3. Now it's in the form of y equals mx plus b, which is slope-intercept form. Therefore, that is my final answer. Questions or thoughts? Can I clear this? Right here. Perpendicular lines. So parallel lines are lines that never intersect. Right? They run like railroad tracks. What are perpendicular lines? They're lines that intersect in such a way that they form 90-degree angles at their intersection. These are perpendicular lines. Now, I don't have a cool thing for you to learn how to tell if they're perpendicular like we did by graphing before. I'm just going to tell you. Perpendicular lines have opposite reciprocal slopes. And so again, the converse of this, oh my gosh, how did it tie these words together? That's so random. Perpendicular lines have opposite reciprocal slopes, and lines with opposite reciprocal slopes are perpendicular, which is just the converse of the original statement. I'm fixing to get there. I'm fixing to talk about both parts of it. Opposite and reciprocal. Everybody have this written down? I'll go to the next slide. Okay. What does opposite reciprocal mean? Let's start with just reciprocal. Does anybody know the definition of reciprocal?
Is it when you like flip the fraction?
That's correct. It's flipping a fraction. So if, for instance, if I had 3/4, its reciprocal is 4/3. So let me rewrite this. If the original was 3/4, its reciprocal would be 4/3. If the original was 8, its reciprocal would be 1/8. We just turn 8 into a fraction and flip it. Right? We can turn any number to a fraction by putting it over 1. Is everybody good with that? Reciprocals. But remember, perpendicular lines are not just reciprocals, they are opposite reciprocals. What do I mean when I say opposite? We change its sign. So if it was a positive slope, we change it to negative. If it was a negative slope, we change it to a positive. So we change the sign, we flip the fraction. That's the slope of our perpendicular line. 2 steps. What's the equation of a line passing through the point 17 and perpendicular to the graph of y equals negative 1/4 x plus 11? So I know a point on my line, and it must be perpendicular to this line. What do I know about perpendicular slopes? They must be opposite reciprocals. So do I know the slope of this line? What is it? The slope of the line I have underlined is negative 1/4. How do I know it's negative 1/4? Because it's already in slope-intercept form. So because it's in slope-intercept form, I can identify the slope as negative 1/4. My line must be perpendicular to that, meaning the slope of my line must be opposite signed, from negative to positive, reciprocal, from 1/4 to 4/1, which we can write as just 4. So the slope of my line is 4. What else do I know about my line? It goes through point 17. I know a point and the slope. A point and the slope. Point, slope, form. Substitute in. Y minus 7 equals 4 times x minus 1. And I'm done. Why did I stop here this time instead of continuing on like I did the last time? Yeah, all it asked for was an equation. Did it say it had to be in slope-intercept form? This time it didn't. If you look at the problem before, it did. It said write the equation in slope-intercept form. This time it just wants an equation. This is an equation. I'm lazy. I'm done. Okay? Could I put that in slope-intercept form if I needed to? distribute, and then add 7, right? Here's our next question. I'm given two equations. 3y equals negative 4x plus 6, and y equals negative 3/4 x minus 5. I want to know, are these lines parallel? Are they perpendicular? Or neither one? What do I need to do in order to find out if they are parallel or perpendicular? I must compare their slopes. Right? Everything comes down to their slopes. Do we know the slopes of both lines? Not in its current form. We don't. Do we know the slope of this one that's in blue? Why not? Because it's not in slope-intercept form. It's close, but it's 3y equals negative 4x plus 6. So before I can tell you the slope of this line, I need to get it in slope-intercept form. So let's work on that. 3y equals negative 4x plus 6. To get it in slope-intercept form, I need y by itself. Y is being multiplied by 3. So I'm going to divide by 3. We have to divide everything by 3. Making this y equals negative 4/3 x plus 2. Can I tell you the slope now? It's negative 4/3. What about my second line? Do I know the slope of it? Already know it. It was already in slope-intercept form. So its slope is negative 3/4. Are the slopes the same? No. It's not parallel. Are the slopes opposite reciprocals? No. It's not perpendicular. So the answer here, it's neither. They're the same sign reciprocals, not opposite reciprocals. Change the sign, flip the fraction. We good with that? A landscaper plans to install 2 new paths in a park. The new fountain path will be perpendicular to the east path and lead to the fountain. The new picnic path will be parallel to the fountain path and pass through the picnic area. What are the equations in point slope form that represent the new paths? Okay, so what is it that I know as I'm making 2 new roads? Let's focus on one road at a time. Let's start with the fountain path. The fountain path is going to be perpendicular to the east path, and it's going to go through the fountain. So let's start with, it's going to lead to the fountain. The fountain path must end up here at this point. What is this point? 15:2. So I know a point on the fountain path, which is 15:2. What else do I know about this new fountain path? It must be perpendicular to the east path. Here's the east path. So I need to be able to find out the slope of this line. The slope of the east path. So I'm looking for points that are on crosshairs. This point looks pretty good. And this point looks pretty good. Right on the crosshair. So, given 2 points, how can I find the slope of this line? I could use the slope formula, right? y2 minus y1 over x2 minus x1. But because it's graph, I'm just going to do the rise over the run. And just count. How much did I rise? 1. How much did I run? 1, 2, 3, 4, 5. So I rose 1, I ran 5, meaning the slope of the east path is 1/5. Now, what about my new line? My new road? It must be perpendicular to the east path. So being perpendicular to a line whose slope is 1/5 means my line must have a slope of -5. Opposite reciprocal. So again, what do I know about my line? I know a point and I know the slope. Point and the slope is point slope form. Y minus y1 equals m times x minus x1. This is the answer to the first line. Any questions on that? All right, the second line, a picnic path will be parallel to the fountain path. Parallel to the fountain path. The fountain path is what I just found here. If it's going to be parallel, it's going to have the same slope as this fountain path. This fountain path had a slope of -5, meaning the slope of the picnic path is going to also be -5. What else do I know about this new road? It must go through the picnic area. Where is the picnic area? At 5, 6. Meaning I know a point on this new road. So what do I know about my new road? A point and a slope. If I know a point and the slope, I can use point slope form. Y minus y1 equals m times x minus x1. Any questions there? How we did that from a drawing? Again, it's just the same steps. You just have to set it up.